You gentlemen have been here before. We're going to start off with avoiding interference. I guess my question, first of all, is, make this easiest, do you understand 110 and 220 volt? What color wires make that up and everything? You know how to wire an outlet?
Yes.
You know the difference between white, black, and green?
White's neutral, black's hot.
Yeah.
Green's ground.
And if you get up into 220 and such, then you're going to have a red wire, which is hot. Your neutral will always stay white, and black always stays hot. That's the way it's supposed to be. So, QRM, if you were the old school, that's what they used on CW. That means that there's interference someplace.
Remember, M man-made, N natural.
Yeah.
You get QRM and QRN.
There you go. A lot of it comes from AC line, could come from feedback. I saw one today where a guy was asking me, he says, my line at 5 feet from the transmitter gets hot. Well, that means that the coax cable, somehow or another, either got bent or smashed. And anytime there's resistance, it builds up heat on that part. So we're going to do something a little bit different, probably what you're used to. The three of us are going to pipe in on all of this stuff using our experience. Okay, what kind of interference to other devices can a ham station cause? Well, in the old days when everybody had television antennas out on the outside of the building, if their wiring wasn't properly shielded, properly connected, you could cause problems. Okay? The answer for this is a broadcast AM or FM radio may receive an amateur radio transmission because of the receiver is unable to reject strong signals outside the AM/FM band. Now, if the station is not functioning properly, it may emit signals outside of the designated or intended transmission band. There's other things that could happen. Like I said, the coax could be bad. You don't have your station properly grounded. We'll get into that in a little while down the slides. That is, grounding is so important. I can't stress it enough. Grounding is a key, and most of the time when you have interference problems, it all falls back on grounding as such. So, what kind of interference to other devices can be harmful? Another answer is fundamental overload, harmonics, and spurious intermissions can cause radio frequency interference. Well, spurious emissions are undesirable frequencies emitting outside the intended bandwidth of the transmit mode. One of the things we run across today are the Chinese Baofeng handhelds. They do cause interference when transmitting. They will sometimes be out of band a ways, and it really messes up a repeater. They're on 2 meters and 440, and when they're out of band, it really does a lot of craziness. Now, our group has a lot of linked repeaters, starting up at the Sioux, Mackinac City, Sheboygan, Petoskey, on down to Traverse City, on over to Mayo. These type of interferences will go all the way down the line and interfere with every one of those repeaters. So that does happen. You got anything?
One thing I also watch out for too is spurious emissions. A lot of stuff people buy on Amazon and stuff like that, they're manufactured in the US or manufactured in China and stuff like that, where the regulations aren't as strict. So simple as a power brick for your laptop, that can easily send out RF signal that'll make your HF radio, stuff like that. It'll cause it to buzz, stuff like that. So there is some benefit to the stuff that actually is FCC certified. That some have fake labels on there. There's not much you can do. If you get really into HF, you'll probably be bugging your neighbors, going over with, toroids or something like that to wrap on the cords. So, because you'll run into it. So, it's
Again,
really
grounding is
cool.
important.
Yep,
Yeah.
and grounding really gets rid of that. It really does. So,
Okay, something else that you're going to run across now, we're going to LED lighting. The good LEDs are good. You start getting the cheap China, Korea, they put off some really funny noises. You can even pick them up on 2 meters and 440. They definitely will mess with HF on those bands. Okay, what kinds of interference to other devices can a ham station cause? RF in the shack or feedback. A ham radio transmitter can cause interference to itself when transmissions are conducted onto the microphone cable or other station cables. Again, go back to where the coax had been crushed, bent. In other words, especially on coax that has the foam feed in it in the center instead of a neoprene center. They, when you bend them, will push the foam out of the way and will contact with the grounding part of the outside shield. And then you're going to get feedback. Feedback on the microphone is a big thing in HF. Not so much in the 2 meter 440 bands per se, because they're pretty well shielded and simple. It's when you start getting up into the HF frequencies, you have 2-wire microphones, some are 4, but most of them are just 2-wire, not shielded, so you can pick up there. Okay, so you'll have the answer to this question of what kind of interference to other devices can a ham station cause. Reports of a garbled, distorted, or unintelligible voice transmission are symptoms of RS feedback into a transmitter or a receiver. Okay, often moving the antenna a greater distance from the transmitter and microphone can alleviate a lot of the RF. Again, it goes back to grounding. Distorted audio caused by RF current on the shield of a microphone cable can be cured by using a ferrite choke. There's examples over here on your right to what they're talking about. This choke here, you wind it 2 to 3 times around it, lock it shut, and that usually will take care of the problem. Those ferrite chokes too, the black round ones, can also be used on your incoming power line, especially on mobiles. They should be used close to the battery, and then again, close to the radio. And that usually will get a lot of your alternator noise, will help eliminate that. Of course, there's other square blocks that can be used also in different areas. This style here is for a larger coax, but you need to wrap it at least once. 2 is the best way to help out. Dylan, got anything?
With the coax line width, Chuck was talking about if you bend it, it's possible that the inside connector can breach through the neoprene or is on the inside the diode in there, so it connects both together. You can actually look at the manufacturer specs on your cables to see what they recommend for your bends. So if you're buying a certain brand, you can see what they recommend. So if you're doing a weird run or something like that, it doesn't hurt to check into that, just so you're not rerunning cable and stuff like that because you accidentally bend it too far and stuff like that. So it comes in.
RG8, RG58 are the two. 58's used in vehicles, RG8 is used in the home. Those are the two that usually have the good center insulation between the copper center and the stranded grounding. Huh?
Buy from a good source.
Yeah, buy from a good source. Don't buy cheap. If you see it at half the price of anybody else has some cable, you know it's junk. Huh? Yeah, Mike, you can jump in there, Mike. Don't be afraid. Okay, any questions on that? All right, whoa.
As I say, I've gone as far as putting Faradites on the incoming power, grid power, into the house,
Yeah,
so.
because of LEDs, generators, you know, that's a big problem right now. Now, how are common interference problems solved? With HF, you'll see over here, versus TV filters, you can put those in line just before the television and your coax coming in. The biggest problem with television interference is the cable companies. They're kind of sloppy when they make their connections as such, so interference can get in semi-easily a lot of times. You even have telephone RF filters. AT&T was big when they started their modems. They'd always send a RF filter along with their stuff. But you got 3 different kinds of filters there that can be used. The 2 metal ones are basically for coax. Those would be for 59, RG59 that most televisions use because it's only 50 ohm, where we're using 75. Okay, how are common interference problems solved? Fair choke is a common solution for any conduction of RF onto audio cables of any type. However, an interference where certain RF is desired and RF is undesired, RF filters may be used. You'll also have RF filters when you get into HF in the rig itself that you can place into them for different frequencies to help you out. Okay, a filter specifically designed to reject the commercial FM band would be installed at the VHF transceiver antenna port. So if you're near a broadcast station, you could possibly have interference on that. Your broadcast, most of your broadcasts now are running 100,000 watt. That's putting out some good power. So that can sometimes cause that. Not all the time. In the new transmitters that are solid state, you don't have that much problems compared to the old tube type. Okay, what's going on here? Okay, how are common interference problems solved? Okay, before trying a filter connection, it is prudent to check other basics in some cases. Okay, the answer is first step to resolve non-fiber optic cable TV interference caused by your amateur radio transmission is to be sure all TV feed lines, coax connectors are installed properly. Like I said before, biggest problem. First step is to resolve non-fiber optic cable TV interference caused by your amateur radio transmission is to be sure all TV line coaxial connections are installed properly. If somebody in the neighborhood starts complaining to you, ask them if you can go over and check. And the easiest way to find out if the cable is not properly, you will see braids coming out of it, and the connection will be kind of not totally circular or round connection. It'll be kind of oblong or wonky. Wouldn't you say, Mike?
Oh, yeah.
The easiest, that's a dead giveaway that they're wrong. 2 things you can do, if you've got the tools and you know what you're doing, you can cut the end off, put a new end on it, connect it properly, or make them call their cable supplier. That doesn't just happen in the homes. That happens out on the lines. Now, with most of your providers going to fiber, it's a whole new ballgame. Spectrum's still running 58 into the box and into the house. So some of those guys get sloppy. And there's others, they're perfect. They just do a great job. Okay, if a neighbor tells you your station's transmissions are interfering with their radio or television reception, make sure that your station is functioning properly and that it does not cause interference to your own radio or television when it's turned on to the same channel as the neighbor's device. That's the first, number one way to find out what's going on is if you're not having trouble, you can then go help your neighbor with a coax problem.
It's getting better nowadays because they're going to a digital box.
Yeah.
So they're not doing the old broadcast over the cable. It's basically a computer receiver. So.
And I know Spectrum, at least in my area, they don't even do cable boxes anymore.
Right.
They're doing basically a Roku box that connects into your TV, that connects into the Wi-Fi that they provide. So.
They're getting better because they've had too many complaints. How are common interference problems solved? Well, common interference to ham radio receivers is broadband noise from power lines and from other electrical devices. Simplest way, taking a handheld and a directional antenna are often sufficient for locating broadband noise sources. Most of the time, it will not be a box like this. It'll be a transformer on a pole or another source. I ran into this in Mackinac City back when I was in the fire department. If you look at a power pole, okay, first of all, the very top across pole to pole, you'll see at the very top, that's basically a grounding wire. And each one of the poles has a cable connected to it, and it runs down the outside of the pole to the ground. Now, as you get closer to the ground, they usually have a wooden shield across it so that people don't touch it. The reason for that is if that cable somehow or another up there breaks at the very top and falls over one of the transmission lines, you've got direct power coming right to the ground. My favorite saying is, whenever you're doing anything with RF or anything, look up first, and then bring your sight down all the way to the ground. And around power poles, be very, very careful of that grounding wire. The one we had in Mackinac, they said our DPW supervisor found it, and it was pumping out some power. Somebody could have just stepped on the ground, could have been electrocuted. It was that powerful. So you have those kind of things. But transformers, and what it usually is, the top of the transformer where they connect in, they've probably got 2, 3 ceramic insulators. 1, 2, or 3 of those could all be cracked, and that's where you'll find it. And if you call and talk to them and say you want to talk to an engineer and tell them what your problem is, they will usually, if you're congenial with them, they'll be congenial back, and they will come fix the problem. Sometimes it gets a little hairier than that, but always ask for an engineer, because the one answering the phone has got a book in front of them, and they got to follow the dum-dum speech, as I call them. Yeah. So that's how you look there. Okay. Radio direction finding is a method used to locate sources of noise, interference, or jamming. If something in a neighborhood home has caused harmful interference to your amateur station, you should work with your neighbor, of course, to identify the offending device. Politely inform your neighbor about the rules and prohibit the use of devices that cause interference. Make sure your station meets standards of good amateur practice. That's an answer to that question. There's 2 answers in there that you may find on the test. No matter what you do, politeness is number 1, and cover your back end. Make sure your stuff is right. And like we were saying, grounding is number 1. It's number 1. I think, if I remember going through this, we'll get into that in a little bit. Okay.
And a big part of the community, the amateur radio community, is there are all
Oh.
sorts of us all over the place. Hey, I think I've got a problem, can you?
Yeah, and you'll have 2 or
And
3.
you'll have a bunch of guys show up with stuff, you go, how are you doing? And they're like, don't worry about it, we got this.
Yeah, I mean, that's one thing about the ham community. We all work together because we don't want people cutting us down. There's too many things, and the ham community is starting to grow back up again. And we're glad you're here in the class. Okay, a brief sideline on base station grounding. This is important. Is it? Huh?
I'm surprised this is not on the test.
Yeah, I am too.
There's some question about grounding in there, because I was looking at a couple practice tests last night, and there's be sure to avoid X on there. Be sure to avoid this when grounding your station. I think the answer they were looking for was the hard corner or something like that.
Oh, yeah, if you end
The
up.
hard bend.
The hard bend, yeah. And we've been talking about, it doesn't matter whether it's a grounding wire, transmission wire, never 90 degree it, never. Because electricity, okay, if you get hit by lightning, electricity goes to the simplest path to ground. If you got a 90 in it and you got like a lightning coming through, it's going to go right through that to find a different ground. It's not going to curve down. As you see here, station grounding, they recommend 8-foot rods.
Especially up here.
Oh, yeah.
Because of freeze, thaw, all those types of things. You've got to get it far enough down into the soil.
Below the frost line.
Yep, exactly.
Otherwise it's gonna
Did Jim do a class?
cook? Yes.
Jim's our expert on grounding. He used to work for Bell Telephone in the United States Army as such. And he's a firm pusher of single source grounding. That means your house, your radio, everything on a single source. A lot of times that's impossible, huh?
That is code.
Well, yeah, that's code. But a lot of times it's impossible to do because you got to run your wires so far and there's 45 degrees and everything in there. So if you've got a new house or something, if you can get as close to your power ground, and I'm amazed how sloppy some of the electricians get with grounding. If you're in a village or anybody that's got a water supply, they like to go to the copper pipe. Problem being, some of the connections are not copper. And you've only got a short 10, 15, 20 foot, doesn't go out to the water pipe. Now, the only salvation you got in there is the water contacting that copper will be a ground.
That's not a preferred ground, though, especially fresh water.
Yeah, you want, really, earth ground is the best. One of the radio station, well, he's no longer an owner, he's just an engineer. He liked putting wells in all his stations for ground, because it'll go to water quicker than anything. Here they're showing you just one rod down. It's been proven, especially if you put up a tower, you go out from each leg, and usually there are 3 legs, and then you make a spider web connecting them. Every 6 inches out this way, you make a complete 360 all the way around, connecting all 3 of them, so that you've got a spider's nest sitting out in the yard around your tower. Best grounding you can do. And then running the 8-foot rods into the ground. Simplest and easiest. One thing is, never daisy chain. And everybody does it. And it's not recommended. In fact, it's against code that you do the daisy chain. Do like the first one is, run your separate wires down to your ground. Single point ground is the best, but each one of your units that you have should be singled out and down and out. Okay, how do hams handle QRM? Interference from other amateur stations is a problem in the single sideband mode, more than with FM. Since single sideband operators do not have established band plan channels for phone operations, well, the term that describes the ability to receiver to discriminate between multiple signals, selectivity. a term that describes the ability of a receiver to discriminate between multiple signals. Again, there's filters within your radio to take care of that. Single sideband filtering. For single sideband reception, a receiver filter bandwidth of 2400 hertz provides the best signal to noise ratio. And usually in a good HF rig, you'll have that already there. There are other filters you can purchase, and I'm going to tell you ahead of time, they're not cheap. Such. Okay, the receiver selectivity is the function of multiple engineering factors, but the most relevant to the operator are filters that allow adjustment of the receiver's bandwidth to match the operating mode. Having multiple receive bandwidth choices on a multi-mode transceiver is an advantage that permits noise or interference reduction by selecting a separate filter for each mode. I'm kind of surprised they have this in the Technician, because this is really related to HF. Kind of shows you the CW signal, what happens in adjoining single sideband.